Yes, good morning, my dear students. Now, welcome to the video number 5. In this video, I am going to discuss dielectric breakdown. What is dielectric breakdown? What are the different types of dielectric breakdown? Piezoelectric effect. Applications of the piezoelectric effect. Next is electrostructure. Whatever the things I am discussing today in this video number 5 now, it is all only theoretical. Normally, you will get 4 mark or 6 marks question you get. Either you get derivation or this descriptive part you will get. But in this today what I am discussing, it is only what? Theoretical part. And listen, if you listen carefully, it is nothing in it. No need of any repetitive. The reading is also not at all required. Okay. First time, before going to this definition, I will tell you what is dielectric breakdown. As you know that all dielectric materials are what? All dielectric materials are insulators. It is an insulator. All dielectric materials are insulator. It is a bad conductor. The difference between the dielectric and insulator is what? On the dielectric, what happens? The induced charges are what? Present and all that, as you know that. Okay. On this material, I will apply the voltage, variable voltage I will apply it. Variable. I will go on increase the voltage. 100 volt, 2000 volt, 3000 volt, 5000, I will apply it. At one point of time, what happens now? It loses its insulating property. Then it becomes a good conductor. That is what? Good conductor. Insulator becomes what? It becomes a good conductor. Good conductor. Because of what? Applied voltage. When there is a voltage there must be electrical field. What is the direction of the electrical field? Here this is the positive terminal, so that this is plus, this is what? Minus, this is the direction of the what? Electrical field. Because of this, as voltage increases, electrical field is increases. As a result, then what happens? The material, the breakdown in the material will what? Takes place here. No longer that material becomes insulator, it becomes a what? Good conductor. Right. This is, now I will get the definition. It is the maximum electrical field that a dielectric material can withstand. It is the maximum electrical field that dielectric material can withstand without it destroying the insulating property is called as a what? Dielectric breakdown. Or I will define in another way also here. It is the minimum voltage. It is the minimum voltage required to produce the what? Dielectric breakdown. It is the minimum voltage required to produce the what? Dielectric breakdown. Here I know that equation, electrical field equal to potential divided by D. D nothing but thickness, students. Thickness of the material. Thickness of the material. The unit is volt per millimeter, or some books they will write volt per meter. For many of the dielectrics, this electrical field, that is breakdown electrical field is of the, that is, it is how much, its dielectric breakdown is measured in what? Volt per meter. It is of the order for air. It is 30 into 10 to the power of 6 volt per meter. For air, very high. Mica, it is what? Mica, roughly it is 120 into 10 to the power of 6 volt per meter. This order is important here, 10 to the power of 6 and all that. Most of the insulators now where the breakdown will be occurs very at very high voltage and all that. Okay. Next is, there are different types of dielectric breakdowns are there. What are that? First one is intrinsic breakdown. Intrinsic breakdown. First one is intrinsic breakdown. They will ask you a question. Write a note on the dielectric breakdown. Just you write the definition, you write, and also what? The types of the breakdown you write. Intrinsic breakdown. Next is thermal breakdown. I will explain in detail what is that. Thermal breakdown. Thermal breakdown. Next is electrochemical breakdown. Electrochemical electrochemical breakdown. Electrochemical breakdown. Next one is discharge breakdown. Discharge breakdown. Okay. Now I will discuss one by one. What is intrinsic breakdown? First one is intrinsic breakdown. One minute. Right. Intrinsic breakdown. Recall your band diagram. Semiconductor, insulators and all that. The band diagram is same. It is for the semiconductor and insulator. It is in a conduction band. It is conduction band. This is what valency band. Valency band. And this is nothing but what? Energy gap and all that. This energy gap E I will express in this equation. E into what? V. Here normally all electrons are present in the where at normal conditions it is in the valency band they are present. And now you apply the voltage for it. In order to jump the electron from the valence band to the conduction band, this much of voltage is required, where V equal to EZ divided by what? Very high voltage is required. When you apply the high voltage to this material, that is nothing but dielectric material, whatever the band is there, now that band covalent bond or what it will be, the band structure will be breaks up. Once the structure breaks up here, the electrons will jump from the valence band to what? Conduction band. The word itself indicates that conduct, where the electrons can move freely, that is. Where the electrons are moving under the influence of the electrical field. Because you are applying the voltage. I know the equation, electrical field equal to voltage divided by what? Distance. Here electrical field is there. In this, force is experience, force equal to E into what? E that is. And when there is a, according to Newton's second law, ma equal to what? E into E. Therefore, acceleration equal to what? E divided by what? M. Here all electrons are gets what? Accelerated here. When there is an acceleration, there must be a mobility here. And these highly mobile mobility electrons will be hits on the what? Another items and all that. As a result, there is more and more number of electrons will be what? That liberates out. This stage is called as a what? Avalanche breakdown. It is called as a what? Avalanche breakdown. This is how that is intrinsic breakdown will be occurs. And second point is, what are the factors on which the intrinsic breakdown is occurs? It occurs in very thin samples. First one, it occurs in thin samples. Sample size will be very, very thin and all that. Next one, it occurs at very high voltage, at very high applied voltage. At very high applied. You may ask question, why it is applied voltage is very high? As you know that in this energy gap here, it is more than 7 electron volt is there for the insulators. More than 7 electron volt. If you want, you can calculate Ez equal to E into V, V equal to Ez divided by E, substitute all the values, 7 electron volt. And here you see it is voltage, then you substitute the electron charge and all that you get, then and electron charge you know that 1.602 into 10 to the power of 9 minus 19 and all that substitute, very, you will come to know that very high voltage is required. Third point is what? It does not depend upon size and shape of the material. It is does not depend on size and shape of the material. Size and shape of the material. Okay. These are the characteristics of what? Intrinsic breakdown, that is. Next one is here. Thermal breakdown, it occurs when there is a heat generation is more than the what? Heat dissipation. Heat generation is what? More than the what? Heat dissipation. When there is a heat generation is more, then certainly the temperature of the dielectric material is what? Increases. As temperature increases, it converts solid dielectric materials into what? Liquid dielectric material. It melts. It melts. When the substance starts for melting, then what happens? There is a free electrons are there. When there is a free electrons are there, then definitely it acts like a good conductor. It acts like a good conductor. This is nothing but what? Thermal breakdown here. That is. I'll repeat once again. Just you go here. What happens is the heat generation is what? More. Once the heat generation is more, then what happens? That is temperature is increases. As temperature increases, then all solid dielectric material starts for what? Melting. That is a semi-state between solid and liquid state. At this stage, what happens? The free electrons are there. Those electrons are responsible for the electrical conduction. Once the material starts for conducting, it is no longer it is insulating material, but it is a conductive material. This is about the thermal breakdown. This thermal breakdown, it depends first one. It depends on size and shape of the material. Size and shape of the material. Recall it. In the previous one, it does not. It does not. But it depends. But here, it depends upon the size and shape of the material. And second point, it occurs within a time, with less time, within a time interval t is nearly equal to 10 to the power of minus 3 seconds. Third one, that is, it occurs at very high temperature. It occurs at very high temperature. As you know that in all your mobiles, sometimes there is if the battery is not so good quality, where the mobile, when you start for talking the near more than 20 minutes, 30 minutes, some of the mobile will be what? That is unbearable amount of heat will be generated in the mobile, that is because of overheating and all that. The battery will be gets into overheated. Sometimes there is a possibility that is what? That is a breakdown of the dielectric material. The battery will go into what? Burst and all that. Normally in the newspaper we are reading once in a year and all that. That is some mobiles will be what? The bursting of the mobiles and all that. It is because of what? Thermal breakdown occurs in your battery, that is. The battery is very important component in your mobile, that is. Quality of the battery is very, very important and all that. Okay. Next one is electrochemical breakdown. Okay, so now that is third one is what? Electrochemical breakdown. It is almost similar to the what? Thermal breakdown only. It occurs due to the electrochemical reactions in the material, that is. As temperature increases, what happens? The electrochemical reactions will be what? Decreases or declines, deteriorates, it is called as declines here. Which gives to what? Once the chemical reaction is decreases, what happens? There is a production of ions. And these ions will be starts for moving with high mobility and all that. As I told you, that is, whenever in any material, if the charges starts for flowing, then it is no longer it is insulating material, but it is a conducting material. As long as the electrons in the rest condition, the material is it is insulating material, and hence it must be a dielectric material only, that is. Because of increasing the mobility of the ions, what happens? There is a leakage of current in the material, that is leakage of current here. It is determined. Now, what are the characteristics of this? First one is, as temperature increases, electrochemical breakdown is increases. Electrochemical breakdown increases. First point. Second, as impurity in the material, if impurity increases, if impurity in the material increases, or as impurity in the material increases, this breakdown is also what increases. Electrochemical breakdown increases. Possibility is what? Increases. And how determined? It is determined by the leakage of, it is very important point, it is determined by the leakage of charges. Leakage of charges. Here, students, remember the electrochemical breakdown is there now. It is almost similar to what? Thermal breakdown here. As temperature increases, what happens? That is, electrochemical reactions will be what? Deteriorates or decreases. Once it decreases, then there is a more and more number of what? Ions will be generated. And those mobility of the ions is what? Very, very high. That leads to what? Electrochemical breakdown. Okay, students. Now, the discharge breakdown. Here there are two types of discharge. One is external breakdown. First one is external breakdown. And second one is internal breakdown. Okay. What is external breakdown? Here a little bit knowledge of electrostatics is required. This external breakdown occurs when the electrode is there. No, one is positive and negative. This electrode, if it is pointed shape, this is pointed shape. This is the positive, and this is what? Negative. This also what? Pointed ends. Always at the pointed ends, what? This is the defects in making the electrodes, positive and negative. That is, as you know that in all the batteries they mention plus and minus. That is called as what? Electrodes. On the electrode at the pointed end, you see there is a more number of charges are accumulated here. That means charge density is more. You might ask question, why the charge density is more? Charge density equal to Q divided by what? Area. Charge divided by what? Area. At the pointed ends, the area is less. When the area is less, then charge density is what? More. If area is less, then sigma is what? More here. Then if the sigma is more, what to do with this here? Here, there is a repulsion between this charge and this charge, this charge and this charge, because they are according to the Coulomb's law and all that. The distance between the two charges is very less. As a result, this leads to what? Leakage. Leakage of charges. Leakage of charges. Come to this point. Here there is a leakage of charges is there. Where they are more here? At the pointed ends and all that. On which here? On the electrodes and all. This is produces because electrical breakdown occurs. External breakdown occurs because of defects in the what? In manufacturing the electrode and all that. Next one is what? Internal breakdown here. Internal breakdown. Here also there is defects in the crystal, not crystal, dielectric material. Here, while manufacturing only, sometimes there is a cavity is formed here. There is cavity, this cavity. Cavities are the defects in the insulating material. These cavities are filled with what? Either filled with either gas or else what? Liquids. As temperature increases, what happens? The gas will be expands. The liquid will be what? Expands here. Here there is a stress increases. Stress in the cavity. Stress in the cavity increases. Stress in the cavity increases. Which leads to what? Which leads to what? The breakdown is. Once it is breakdown occurs, there is a free charge carriers are what? Present here. Once the charges are free, then no longer the material behaves like an insulator. It becomes a good conductor and all that. Then What are the characteristics of this? Here, it depends on the number of times you are doing charging and discharging. It depends on number of times charging and discharging of battery is made. Why I am using the word battery? All the batteries are what? Composed with what? Dielectric material and all that. Here I will tell you that is. Always that is. Whenever the battery is what complete, it is nearly about 80% charged. It is a normal human tendency is that again we will put for the charging, that is. No, wrong it is. Don't put for the charging repeatedly, that is. Unless it becomes less than 14% or 15%. If the battery is almost, if it is 50, drain out by 15% now, then only you do the charging. Otherwise, no, that is. Even if 16% also, don't go for the charging. Allow it for the discharging. Always, whenever any battery, if you do repeatedly the charging and discharging, if you do it now, the life of the battery is what? Decreases. Second one is defects in the dielectrics. Defects in the dielectrics. If there is any defects in the dielectrics are there now, due to which defect in the dielectrics, due to which this is what? Internal breakdown increases. Due to which internal breakdown increases. Students, anyway, I explained the dielectric breakdown and different types of what? Dielectric breakdown also I explained. What is that? Once again, just I will recapitulate. It is the maximum the electrical field up to which the dielectric material can what? Withstand. Maximum amount of electrical field can withstand. Beyond which what happens? It is insulating material. It becomes what? Good conductor. What is the unit of this? Volt per meter. What are the different types of breakdown are there? Thermal breakdown is there. Intrinsic breakdown is there. Electrochemical breakdown is there. And another one is discharge breakdown. Depending upon the marks, you should write. Suppose if you ask particularly about thermal breakdown, you write it. Suppose if you ask the particularly about intrinsic breakdown, you write only about the intrinsic breakdown. Just you only should modulate your answers based on the questions and marks also. Next one is piezoelectric effect. Piezoelectric effect. Students, piezoelectric effect. In our daily life, we are using this one. Where all I'll tell you within a few seconds. The term piezo means pressure. Piezo means pressure. Here, there are two types of piezoelectric effect. Is there? One is a direct piezoelectric effect. Piezoelectric effect. Piezo means pressure. Second one is indirect or reverse. Indirect piezoelectric effect. I'll give you a very good example for the piezoelectric effect. Your lighter. Which lighter? The B.Sc3 lighter. Do you know that the B.Sc3 lighter, when you press it at the end, what happens? A spark will come now. A spark will be what? Arises. There, you are applying the stress is applied. Stress is applied on the crystal. Stress is applied on the crystal. There is if you want, you can dismantle your lighter and then check it. There is one crystal is there. Here, it produces the what? Electric polarization. That is what? Electric polarization is produced. Electric polarization produced. It comes under the Example of what? Direct piezoelectric effect. See, whenever the stress is applied on the crystal, then what happens? On one side, on the opposite face, either this face or this face, or the face, this face or this face, one will become positive and another will become what? Negative. This is called as in what? Direct piezoelectric. It is the phenomenon, I will explain, the phenomenon in which ferroelectric material becomes electrically polarized. The phenomenon in which the ferroelectric material becomes electrically polarized when a mechanical stress is applied. Stress means force or pressure. Mechanical stress is applied is nothing but piezoelectric effect, or sometimes it is called as what? Direct piezoelectric effect. I'll repeat once again. It is a phenomenon in which the ferroelectric material, it becomes electrically polarized. Electrically polarized means one side it is completely positive charges and another side it is what? Simply the negative charges are there. By applying the what? That mechanical stress. This phenomenon is called as what? Direct polarization, or only, sorry, not polarization, it is called as what? Direct piezoelectric effect. Very good example is your lighter, that is lighter. And next one is, even that you know that in all the high-end cars and all that, there is a airbags are there. How the airbags will work? It is based on this only. Whenever the accident occurs nowadays, there are some sensors are there. Those are called as pressure sensors. All pressure sensors are made by what? That is piezoelectric material. That is what? Ferroelectric materials and all that. It based on the stress, that is based on the, that is what? The stress. Now what happens? Now there is one side material gets what? Positive charge, and another side it will gets what? Negatively charged. These signals will be triggers on the what? Another automatic circuits and all that. As a result, that is the airbags will be what? Open and all that. Airbags will be, in the airbags, what are there? The pressure sensors are there. The pressure sensors are made up of what? Piezoelectric materials and all. Ferroelectric materials. They will call it as a what? Ferroelectric material. Whenever there is an accident occurs, there is an impact is there. There is what? Mechanical stress is there. This mechanical stress leads to what? Polarization is there. This polarization, it will send the signal to open the what? Airbags and all that. And very good example I told you, it is what? The lighter also. Next one is indirect piezoelectric effect. Here, applied voltage, that is AC voltage on crystal, on material, on crystal leads to what? Stress. Stress is produced. Stress is produced. Exactly reverse of it. This is called as what? Indirect piezoelectric effect. So, we have to ask question, is there any example for this? As you know that in all your watches, there is a quartz crystal is there. There is a quartz crystal. That quartz crystal, it is connected to this crystal, it is connected to the battery. It is connected to the battery. One is positive and what? Another one is what? Negative. As a result, the deformation in the crystal takes place. This size of the crystal, it is like this. This is the crystal. Now I am applying the voltage. I am applying here alternating voltage. Now, as a result, this one is there. Now it starts for oscillates. The crystal will be what? Oscillates. If I remember correctly, this quartz crystal, I think in 1 second, 36,718 times it oscillates in 1 second. Because in all quartz crystals, it's a natural property that is. As the crystal oscillates, then what happens? The second needle, minute needle, also what? It will be starts for rotates on your watch and all that. This is a property we are making use of what? In watches and all. You may know that quartz watches and all that. In the quartz watches, what happens? There is indirect piezoelectric effect. What is indirect piezoelectric effect? where applied voltage, you are applying the voltage in the crystal leads to stress is produced on the what? Crystal. What is stress? Where the expansion and contraction of the what? The crystal will be takes like this. It will oscillate constantly. It will be oscillates. This crystal is present in all your the computers also. The clock is there. Computer clock, laptop. Inside the laptop also there is a clock is there. Even in your mobile also there is a clock is there. Just switch off your mobile and again you on it. Will it show any the lagging in the time? No, it will show the correct time always, because inside there is all your device, either it may mobile or laptop, whatever it may that is, always that crystal is constantly is provided, is connected to the battery and all that, so that it will be oscillates with the correct frequency and all that. That's why all mobiles will show the correct time and all that. This is the applications of the piezoelectric effect. And one more application is there here. They are used in the microphones and also in the transducer. What is transducer? The transducer are the devices which converts mechanical energy into electrical energy. Or the transducers are used in the in the sonar navigation. In the sonar. What is sonar here? Sound navigation and ranging. It is called as sound navigation and ranging here. I will come to that. Here the crystal is what? One crystal is there. This crystal on which it is connected to the that is signal. That is crystal AC voltage. As a result, what happens? This crystal, what happens now? It will be oscillates. When it oscillates, it generates ultrasonic waves. They are the mechanical waves. Ultrasonic waves. And you said in the high school level also, these ultrasonic waves are used in the sonar to detect the enemy navy craft or something. That is what. That's why it is called as sonar navigation and ranging. Don't worry about all these things here. Just to write only this much. Piezoelectric materials where they are using in preparing the transducers. What are transducers? There are two types of transducers are there. One is converts mechanical energy into electrical energy, and another one is electrical energy into mechanical energy. These transducers even they are using in the photocopier machine. That means in the Xerox machine. Even the microphone they are using. In the lighter they are using version, lighters and all that. And also I told you in the airbags and all that. This is about the applications of the piezoelectric effect. Here, how many types? Again, the piezoelectric effect, there are two types. One is direct, and another one is indirect. Indirect, what happens? You are applying the stress, as a result of which, what happens? That is electrically, it gets polarized here. One important point is the student that remember in 2 more questions you may get. What are the conditions for the material to produce the piezoelectric effect? The material should be, what is the condition? What kind of material is suitable for the piezoelectric effect? Asymmetric material. Asymmetric material is correct material for the to produce the piezoelectric effect. Asymmetric material. What is the condition for the crystal to exhibit piezoelectric effect? It is an asymmetric. Asymmetric material means, suppose there is a positive charge here, negative charge, here, negative. It is not asymmetric because with respect to this, here also negative charge is there, the same distance, here also negative charge is there. So the dipole moment is produced by this, dipole moment produced by this, dipole moment is represented by from negative to positive. This is mu1. Dipole moment is represented from negative to positive. This is also mu1. How they are? Both are equal and opposite. So that net dipole moment equal to 0. These are called as a symmetric. Such kind of materials are not at all good response, good material for the piezoelectric effect. But asymmetric means, suppose it is a positive, one charge is negative and another charge is negative here, you see. The distance between them is less. Here the distance between them is more. So that here the dipole moment is less. Here the dipole moment is more here. That's why this kind of material I will call it as a submitted. Please recall it, very, very important one. In 2 mark question, they may ask you that is what kind of material they are using. And remember, that is piezoelectric effect, where all they are using in the quartz crystal, in all your watches, and in airbags, and what in the later, and also what in the sonar navigation and all that they are using, and also in the microphones, and also in the what, in preparing the what, in the Xerox machine, that is called as in what, photocopier and all that. This completes your dielectrics theory part of it. And in next video, I am going to discuss the important part is, that is problems part on it. Thank you, one and all.